Alrighty, so today's lesson is going to start off with the easy ways to measure central tendency. So we are now in Unit 3 of Probability and Statistics, and this unit is broken up into two types of measurements or calculations that we can run on our data. The first type or multiple types of measurements that we're going to be finding are measures of central tendency. So those measures of central tendency are telling us on average what is happening in our data set. And there's different ways we can calculate that. We can find it by finding the actual calculated mean or average, the median, or the mode. And then the second half of this unit is going to be broken up into measures of variation, which is talking about how far spread apart is our data set. So this first group of measurements of central tendency are going to start off with something that hopefully you are familiar with, which is the mean, median, and mode. So make sure you get your notes in foldable and something to write with. Okay. So measures of central tendency is a single number that represents a value around which all the numbers in our data set tend to cluster. That's probably the best way to explain a measure of central tendency, is that one data point that is showing us the tendency that's on average what's happening in our data set. And again, those three types that we're going to start out with today and find is the mean, the median, and the mode. And the mean will always be the mathematical or arithmetic average. Median, remember, means that middle number in our data set. And mode is the number that has occurred the most often in our data set or listed multiple times. Which one was listed the most? All right, let's start off with some vocab before we get too carried away into mean, median, and mode. So a statistic and a parameter, what is the difference? They are both characteristics that measure, is some sort of measurement that we're going to find, a data point that we're going to calculate, and they are obtained by using two different things. For a statistic, it's obtained by using data values from a sample, and a parameter is obtained by using things from a population. So parameter is used when we have a large data set of a population. But for the sake of our class, we're going to be working with small data sets most of the time. So we'll be working with statistics because we'll be working with samples more than parameters. All right. Our first measure of central tendency, the mean, which is also known as the average. Mathematically, it is found by adding up all the items or all the data values and then dividing that sum by the number of items. So again, why did we talk about the difference between a sample and a population? Because in the world of mathematics, we have different symbols for a given sample or a given population. So the symbol for the mean for a sample is noted by this X bar. That's how you would read it, is X bar. So it's the variable X with a bar above it, X bar. That same mean symbol is going to be denoted with a U with a tail on the front and the back, and it's called mu. So the formula then is the sum of all of our data points divided by the total number of data points. So you can write the formula down as the one on the left or the one on the right. Either way, we're going to add up all the items and then divide by the total number of items. All right, here we go. Here's our first example. It says 10 students were polled as to the number of siblings in their individual families. So we surveyed 10 students and we asked them, how many siblings do you have in your family? Here's the raw data set, 3, 2, 2, 1, 3, 6, 3, 3, 4, 2. We want to find the mean number of siblings. Because it's a sample, we'll use X bar instead of mu. So X bar is going to be equal to 3 plus 2 plus 2 plus 1 plus 3 plus 6 plus 3 plus 3 plus 4 plus 2, all divided by our total number of people that were surveyed, which is 10. If we add up all those numbers, 3 plus 2, blah, 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 right? We get 29 all divided by 10. 29 divided by 10 as a decimal is 2.9 siblings. That would be our final answer for the average or the mean. Notice how in that last example we talked about number of siblings. So we're talking about whole numbers because when we talk about people, we should be talking in whole numbers. But the answer that I got for the mean was 2.9, which is not a whole number. So that brings me to this next slide about rounding rules when we talk about measures of central tendency, specifically for the mean. Well, a general rounding rule in all of mathematics is to wait till the very end, if at all possible, to avoid any kind of unnecessary errors or any kind of overestimating. And then the rounding rule specific to the mean, it should always be rounded to one more decimal place than the number that occurred in the raw data set. So, like our example that we just looked at, our data values in our data set were whole numbers because we were talking about numbers of siblings, and our mean was rounded to the tens place. We kept it at 2.9 siblings. It's just showing a little more accuracy so that way we know as the statistician that we didn't round it up to 3, or if we rounded it up to 3, then we would be left wondering if 3 was the true mean that we found as the decimal, or if that's the rounded answer. So we're going to always keep it one decimal place larger than the original raw data set. Okay, moving on to our median then. So median, remember, means middle. So it's going to divide our group of data values into two parts, a lower and a upper, or below half and above half, right? It is the one reason why people prefer using the median over the mean. People sometimes wonder, like, why would I ever use anything other than the average to find the central tendency? The median is not sensitive to extrema. So it sometimes can be a better representation of our central tendency that's happening because the mean is affected by extrema. It can pull our whole entire average down or up given an extreme value. So when it comes to finding the median, it depends on if our data set has an odd number of data values or an even number of data values. And we're going to look at two examples on how to come up with the median given those two types of data sets. So again, we have our 10 students that were polled, and here's our raw data set. It's the same data set, and we're going to find the median. So when we find the middle, before we do anything, we have to organize our data points in order. We can't find the middle until we've labeled or organized our data points in order. So we're going to take these 10 data values that we surveyed from these people, and we're going to list them in order. So our smallest data point was a 1. And then we have some 2s. We have 1, 2, 3 2s. So 2, 2, 2, 2, 2, 2. Then we have 1, 2, 3, 4 3s. 1, 2, 3, 4. 1, 2, 3, 4. A 4, and then a 6. So we have 10 total data values. So we want to find the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Our middle is falling right here. So if we have an even number data set that we're trying to find the median or the middle, what you're going to do is you're going to take the average of those two numbers that fall on either side of the middle. So you're taking 3 plus 3 divided by 2 will get you a median. I mean, you don't have to show this math. Hopefully you know that 3 plus 3 divided by 2 will get you back to a median of 3. So 3 siblings would be our median for this particular data set. All right, let's look at if we had an odd number data set. So if we only had 9 total students that were polled. So again, we're going to start off by listing them in order. 1, 2, 2, 2, 1, 2, 2, 2, 3, 3, 3, 3, 3, 3, and 4, 6. So we took out the one other person that had a sibling number 3. So if we have 9 total data values, we're looking for that fifth 1, 2, 3, 4, 5, because then there's going to be 4 spots on either side, or 4 data values on either side of that middle number. So it's still going to be a median, in this case, of 3 siblings. But you don't have to find the average because since we have an odd number of data values, we can find the exact middle without having to do any other extra calculations. And lastly today is the mode. The number or the numbers, sometimes you can have more than one mode, that occur the most often. So if you have a distribution or a data set that has 2 modes, then we call that bimodal. We talked about that in Unit 2 when we talked about different shapes of distributions. And then sometimes in a large distribution, bimodal can be applied to 2 modes that are not exactly the same frequency, but if they're really, really, really close. So if 2 particular categories stand out of the rest of the distribution, we can still call that bimodal. All right, here's our same example, the 10 students that were polled for the number of siblings that they had in their families. So it's back to that original data set of 3, 2, 2, 1, 3, 6, 3, 3, 4, 2. We want to find the mode. So out of all these, which one was listed the most often? You can just tell, or sometimes people like to write them again in order to see which one's listed the most often. But it looks like we have 4 3s and 3 2s. So the most often, or the mode, would be again those 3 siblings because it was listed the most in the data set. All right, that is a quick recap on mean, median, and mode. Hopefully you've seen those calculations before, but if not, there you have it. And I want to thank you for taking good notes, and I will see you soon.